So in this problem we have a bullet that hits a door. It moves the door through the hinges a certain amount, and we're asked to find the angular speed omega of the door after the collision, and its kinetic energy conserved. So one thing we can say is angular momentum, L, is given by the mass times the velocity times the radius of rotation. And if we plug these in for the bullet, it's 0.010 kilograms. It's moving at 400 meters per second, and the length is 0.50 meters. So this is 2.0 kilogram meters squared per second. The final angular momentum is I, which equals is I omega, where I is the doors plus the moment of inertia of the bullet. Right there. We can't ignore those. The moment of inertia of the bullet is given by ml squared. So that's 0.010 kilogram times 0.5 meters squared, or 0.0025 kilogram meters squared. The moment of inertia for the door we can look up. We find out that it's the mass, this is bullet mass of door times d squared over 3. So this is 15 kilograms times 1 meter squared over 3, or 5.0 kilogram meter squared. So I total then is going to equal the sum of those two. And so that's 5.0 plus 0.0025 kilogram meter squared, or 5.0025 kilogram meter squared. And now we can say that omega is, so this is initial, right? This is final, and if we set them equal to each other, we have I omega equals mvl. So omega by itself is going to be mvl over I. mvl we've already done, right? That's just the momentum initially, and we found that to be 2.0 kilogram meters per second squared. I total is 5.0025 kilogram meters squared. meters squared per second. I have this squared somewhere else. So this gives us 0.40 radians per second squared. And then if we wanted to find the kinetic energy initially, that's 1/2 mv squared, which is going to be 1/2 the mass of the bullet, which is 0.010 kilogram times 400 meters per second quantity squared, which is 800 joules. Kinetic energy final is 1/2 I omega squared, because it's rotating now, it's no longer translation. So this would be 1/2 5.0025 kilogram meter squared times omega, which is 0.40 radians per second, not second squared, and then the whole thing squared, and this gives us 0.4 joule. This is not surprising that the kinetic energy is not conserved. We should have known that from the beginning, because this is an inelastic collision, right? In elastic collisions, we know kinetic energy is not conserved. So